of a single wavelength is incident normally on a diffraction grating. The resultant diffraction pattern is displayed on a screen. So there's a diffraction grating, and then there's a pattern observed on the screen. Which change makes the first orders of intensity maximum further apart from each other? Now, the question is asking you that if this is the diffraction grating, and this is the light that is coming. The light that is coming, if it continues like that, that will give us a zero order. This is my screen here. So this is, let's say, the first order, another first order there. The question is asking, how can we make this angle here bigger? Now, you must understand that the angle of the first order in this equation, d sine theta is equals to n lambda. The angle here between the zero order and the first order is what we call theta. So of course, if we want to increase the angle between the two first orders, we must increase the angle theta. So we want to see what can increase this angle theta, but n is 1, so we want to see what else can increase. So let's determine this before we finish up. We want to increase the angle theta, so sine theta. Since n is 1, then when there is n, I will put 1, then we are left with lambda over d. So the only way to increase theta, remember sine theta and theta for values from 0 to 90 degrees. If you increase theta, sine theta also increases. So we want to know how to increase theta. So if we want to increase theta, we must increase sine theta. So the one way to increase sine theta is to increase the wavelength or decrease the slit separation, or the numbers, the line separation of the diffraction grating, so that we can increase theta. So A is saying placing the screen closer to the diffraction grating. This has nothing to do, on a diffraction grating we don't have this issue of a screen from the diffraction grating. I'll jump B since this is the answer. Then C says using a diffraction grating with more slits but keeping the same separation. So this one is simply saying keeping D constant, small letter d constant. Keeping small letter d constant will not change theta. Then D is saying using light with a shorter wavelength. Shorter wavelength actually decreases the wavelength, decreases sine theta, decreases the angle theta, and actually has the opposite effect. Then the answer B was the answer. Using a diffraction grating with less separation between adjacent slits. So with less separation, so in other words, it means decreasing D. Decreasing D has the effect of increasing sine theta, therefore increasing theta, as we want to happen here. Okay, the next question says, in the circuit